Yeah, so this is the GIS Workgroup's mission. It's a work group that is led by Robert Miller, Kyle Zolovinishek, and myself. It really has a lot of leaders, and a lot of our initial work over the last few years is focused on providing the basic framework for the informatics that eventually is going to support this mission. So we revised our mission, which is now to improve the health of populations by generating reliable evidence from integrated geospatial and person level health data. So those kinds of geospatial data are listed there: climate, toxicants, regional policies, social terms of health, other things, anything associated with where you know somebody's lived that might affect their health. And as we've improved the underlying infrastructure, we're shifting the focus from the informatics to support that to actually doing work that's going to improve health by doing this kind of integrated analysis. Next slide. What that looks like in general, here's a very simple picture of what the typical OHDSI workflow looks like, where health states, clinical care, care provider information generated from healthcare settings is extracted and transformed into the CDM, and standardized best practice analytics are applied in order to produce what it is we all want to produce: the reliable evidence about health impacts. What we've done in this collective group is to add to that a framework and a set of functioning processes and software that allow you to link patient address information through geocodes to data that's extracted from public data sources on climate, toxicants, social determinants of health, et cetera, and extract that after it's been linked through the geocodes into an extension of the OMOP common data model that's fully compatible with it. How the vocabulary work, how the way for defining phenotypes, adding cohort definitions into the Hades tool stack, all of that same thing compatible with it so that you can produce reliable evidence that includes that. Apply the same best practice analytics to approve that. So that's the gist of what this group has done. And we got a lot kind of over the hump in the last year. So there was an extension to the OMOP schema, the thing that you just saw as part of that graph. There's a very extensive set of vocabularies for everything from the kinds of geographic shapes you need to work with computationally in order to link where people live to these exposures. The exposome vocabulary, social terms of health vocabulary, very extensive, very well done, and tested this core vocabulary for doing the work of transforming what those data look like in a public data set into the shape they need to be in order to be integrated. A flexible cataloging approach, so taking and accumulating at a community level information about what data are out there that you might want to use this way. How do you understand what's already been specified in terms of attributes you want to link, et cetera. And we've also changed the process of what we're doing. So gone from kind of very task-focused informatics development work to something that still includes that, but expands it to include use cases where people are taking this infrastructure and applying it to actually estimate health impacts that include both this person level and geospatial data. All of the groups involved have developed roadmaps that are now on this broader GitHub-based infrastructure that we're managing all the different activities, the use cases, and the development work simultaneously. Next slide. So you can go see those roadmaps for this core Gaia infrastructure that does a lot of the transformations, the roadmap for validating the vocabulary that's been drafted and released, and how you can work with that vocabulary locally while it's still in this draft stage as we use it as a standard vocabulary in an expanded test space where the test cases are contributing to our validation of that. The roadmap for all of the cataloging work I just described, the roadmap for advising on how to use the existing privacy-preserving geocoding strategies that are out there. So we're not supporting those geocoding packages themselves. We're kind of describing how to work with them and the pluses and minuses of doing different versions of that, depending on where you are in the world and what your needs are. And containerization, so this local version of a vocabulary, or how to work with the data that you need in order to get the attributes of interest without sharing actual location information. That's done in a container. The process for working with those containers. Again, each of these efforts has their own leaders, and they're all being coordinated through this central GitHub infrastructure. And here's a list of the use cases and some of the people or projects that are involved in leading them. I'm not going to run through all of them here, and I'll just cut to the next slide and say we are meeting on Fridays at 10 a.m. Eastern, and really welcome. We have a good process for evaluating new use cases, helping you understand whether or not this is going to be useful for you, and we look forward to working with you. Thanks.